Beginning in Algebra, Week 1. So glad you're here. Please note that this session is being recorded. No student will be identified by name.
ALEKS Initial Knowledge Check.
This PowerPoint was designed by me, Professor Debbie King. All content is created by me, but we have a famous broadcaster, Vincent Harvey of Emory University.
Thank you, Professor. Here is our agenda that we will be going through. We have 14 math problems by ALEKS plus pop quizzes. We have 9 discussion topics for you to choose from. And we have 8 DeVry Monday Motivation and Wellness Wednesday pop-ups. Warmest welcome and congratulations on accepting the Beginning Algebra Challenge.
I'm Professor Debbie King, and I am beyond thrilled to see you advancing in your educational goals. I am hard of hearing in both ears and birth, so my voice is very different. Feel free to move this presentation. I have included most of my text in the slide. Have a huge round of applause to Vincent Harvey for narrating most of this presentation. He's won multiple oral awards.
Thank you, Professor. All right, so which describes your understanding of algebra? Do you feel like you're an expert? Help! Math is very challenging to you, or learning new things in math is fun for me? Let us know. Math autobiography. Thank you so much for sharing keywords derived from your previous experiences in mathematics. Here is a word cloud generated from the keywords you mentioned. Let's see, we have PEMDAS, please excuse my dear Aunt Sally, otherwise known as parentheses, exponent, multiplication, division, addition, and subtraction. We have show your work. Yes, you got to show your work. We have singing the quadratic formula, always a classic. And, afraid to ask questions? Well, we hope this semester you're not afraid to ask questions. We want you to succeed. Okay, so your first math assignment is to complete the ALEKS Initial Knowledge Check. ALEKS stands for Assessment and Learning in Knowledge Spaces. In this course, your 162 knowledge spaces include whole numbers, fractions, decimal proportions, and percents, real numbers, linear equations and inequalities, lines and functions, and exponents and polynomials. However, before you can access these spaces, you must complete the ALEKS Initial Knowledge Check. After you complete the Diagnostic Initial Knowledge Check tool, you will receive an individualized set of content modules as an ALEKS Pi progress chart. The more problems you answer correctly on the Initial Knowledge Check, the more topics in the ALEKS Pi you may exempt. So let's tackle together some randomly generated ALEKS Initial Knowledge Check problems. Let's make this day great. One of the beauties of mathematics is that there are usually several ways to approach and solve the problem. Feel free to use a different technique than what you see in this video. Journey courageously. Let's start with our Wellness Wednesday. So I'll wait for it to do the full, let's see, so there's the exhale. Okay, so we're gonna get past the hold. So we're gonna start with inhale. So inhale, now we're gonna hold, now we're gonna exhale, and now we're gonna hold. And now you can practice that a few more times and we can get into the problem. On to number 1. Evaluate the following. So we have 2 problems. We have -3 times -5, and we have 24 divided by -6. So, pop quiz, evaluate the following. So for the first part, -3 times -5, what do you think the answer is? Do you think it's +15, -15, -8, or should we wait until we study integer multiplication during week 2? That's never a bad choice. Well, let's see. In the corporate world, they pay you big bucks for thinking outside of the box. Yeah, because 3 + 7 is 37. That's cute. It's 10, by the way. All right. So recall some of these properties. A positive number times a positive number is going to equal a positive number. Makes sense. A positive number times a negative number is going to equal a negative number. A negative number times a positive number is also going to give you a negative number. Now, the fun one, a negative number times a negative number is actually going to give you a positive number. They cancel out. The signs cancel out. So just remember that. We're going to use that. So let's explore the logic financially. Suppose a friend gives you three $5 notes. So there's one, there's two, and there's three. So how much money did you gain? Well, it's three notes, but they're $5 each, so that's a total of $15. Woohoo! You gained $15. We're rich. So there's that first property. Now, suppose a friend gives you three $5 debts. I don't like this friend. So I owe you, and I owe you. How much did you lose? Okay, so three $5 debts. So it's still, they're giving you three, but it's $5 debt, so it's negative. So it's negative 15. So we've lost $15 and we've also lost a friend. No, I'm just kidding. Just kidding. Now, suppose a friend takes three $5 notes from you. Again, I don't like this friend, so there goes my money. How much money did we lose? Well, they took something, so it's negative. So they took three $5 notes. So now it's negative 3 times 5, which again gives us a negative $15 we've lost. So that's the third term. Now, suppose a friend takes three $5 debts from you. So goodbye debt, goodbye debt, goodbye debt. How much money did we now gain? Well, it's a negative 3 because they took something from us, but they took debts from us which were negative. So negative 3 times negative 5 is positive $15. So overall, we gained back $15. Woohoo! We like this friend. All right, so now take a look. It's in a book. This is paraphrasing the Reading Rainbow. So we're using multiplying sign numbers. All right. So again, let's evaluate the following. So we did the first one. Now we're looking at the second problem. So 24 divided by negative 6. So based off of the properties we discussed, do you think that it's negative 4? Should we wait until we discuss integer division during week 2? Do you think that is positive 18 or positive 4? What do you think? Well, let's go through it. So if you can recall from the first problem, 3 times 5 gives us 15. That's multiplication. So if we want to divide, then it would just look different. It would be 3 equals 15 divided by 5, which makes sense. That's 15 divided by 5 gives you 3. So we're doing the same property. So now we have 3 times negative 5 gives us negative 15. But if we divide over, we move the 5 to the other side, we now have 3 equals negative 15 divided by negative 5, which again is going to give us a positive 3. So let's try something different. Now we have negative 3 times 5 equals negative 15. We move the 5 to the other side, i.e. dividing it. And yeah, negative 15 divided by 5 does give us negative 3. The negative still remains. So now let's look at negative 3 times negative 5, which gives us 15. Well, that's correct, because if we move negative 5 to the other side, i.e. again dividing it, 15 divided by negative 5 still gives us that negative value, negative 3.
So in other words, the inverse operation.
Yes, thank you. Thank you, Professor. So we're going to do same song, different verse with this. 24 divided by negative 6 we know is going to equal a negative number because we have one negative number already. And so we can look at the times table. So 6 times 0 gives 0. 6, and again, if you already see this, feel free to move ahead. 6 times 1 gives us 6. 6 times 2 gives us 12. 6 times 3 gives us 18. And 6 times 4 gives us 24. So we know that our final answer is going to be 4 because we need something times 6 to give us 24. And again, that negative number. But hey, check yourself before you wreck yourself. Please consider checking your work with the calculator app, including Desmos as an option. Please only use free calculator sources. There's many great ones. You do not need to pay for a calculator for this course. So again, that topic that we're going to book it, like Pizza Hut said, is dividing sign numbers. Okay, so this is getting into your discussion topics. Why? The ancient question. Why is it important to study mathematics? What does learning and knowing math do to your brain? Select the incorrect statement. According to Dr. Joe Boiler, making mistakes in math can cause your brain to grow. Well, my brain has grown a lot then. Recent research indicates that calculation deficits, such as seniors who are not able to add, subtract, multiply, or divide, are a common early manifestation of Alzheimer's disease. Men's brains are naturally better than women's brains at math. According to the University of Oxford, adolescents who stopped studying math showed a reduction in a critical brain chemical for brain development. What do we think is the incorrect statement? I wonder. Yes, no. They are not naturally better than women's brains at math at all. As a matter of fact, I think more women hold degrees and attend college than men. So it has no correlation. But what is correlation is we want to celebrate your wins. On to number 2. You're doing great. Okay, we're getting into decimals and percentages. So the first task is to write 13.8% as a decimal, and the second part is to write 0.2 as a percentage. Okay, pop quiz. So writing 13.8% as a decimal. If you can see ahead, feel free to move. But do you think the answer is to wait until we study percent to decimal conversion during week 5? Do we think that it's 1,380, 1.38, or 0.138? It's probably not the one that Professor Keene laughed at. But hey, let's analyze the percent sign. So that slash in the percent sign literally means to divide. The 2 zeros in the percent sign indicates the number 100. Kind of makes sense. So you know that the percent sign is literally telling you to divide whatever that number is in front of the percent sign by 100. So we're going to do that. You could also use the two-step dance method, which is my favorite. It's the easiest way to remember it. So that means we're going to move the decimal point 2 spaces to the left. That's the two-step part in this two-step dance. So we have 13.8%. We want to move the decimal 2 spaces. So there's our first one, there's our second one, and now perfect. You gotta add the invisible 0 in front of it too, since it's a point. Because I'm pretty sure Alex would get mad at you if you don't. I forgot where to put the decimal, so I figured I'd cover all the bases. Yep, there's a decimal in every spot. He did great. And again, from your textbook, this is converting percents to decimals. Like I said, I love the two-step dance. It's very easy. Just toot toot. All right. So the second part of the problem, write 0.2 as a percentage. All right, pop quiz. So do we think that writing 0.2 as a percentage is 0.20%, 0.002%, 20%, or should we wait until we study decimal to percent conversions during week 5? What do you think? Well, let's go through it. So recall from the previous problem, to convert from percent to decimal, divide by 100 and remove the percent sign. So to convert from decimal to percent, we're going to do the opposite. That is, we're going to multiply by 100 and insert the percent sign. Again, you can use the two-step dance method for this. So again, recall to convert from percent to decimal, we needed to move the decimal point to the left 2 spaces, divide by 100. So to convert from decimal to percent, we're going to do the opposite. So that is, we're going to move the decimal point to the right 2 spaces. So since we have 0.2, we need to move the decimal place not 1, but 2 spaces. There we go. And that's where we're going to put the decimal. So now we got to insert that placeholder, the invisible 0, in the empty slot like what we did previously. We can also omit the first leading 0 because the decimal is moved. So we have 20 point. Since 20 is a whole number, we can delete the decimal point. So we really only have 20, and again, that last step that we had mentioned, you got to put the percent sign at the end. Now, granted, ALEKS has it here for you, so you just type 20. Don't put percent, please, because otherwise it's thinking you're saying 20%, but I digress. You did great. It is 20. Yes, there's that big old warning. Do not enter a percent sign because the problem already ends with a percent sign. We don't blame you for doing that accidentally, but you will get the problem wrong. We understand your pain. Another way to look at it, if you want to look at it as like a pie chart, is it pie chart or pie graph?
Pie chart.
Thank you. I did say it right. Okay, perfect. I've seen too many charts and graphs. That is 20% or 1/5 of the overall pie. Oh, but our favorite dog is here to help us. This homework looks hard. Would you like me to eat it? Yes. He always loves eating the hard problems. But again, looking at your textbook, it's converting fractions and decimals to a percent form. Math is your chosen profession. What degree are you aiming to get? Research the math skills necessary to your future profession. So for instance, business management majors are more likely to apply which of the following formulas? Is it Ohm's law? Is it decimal to binary? Future value? Or Pareto principle? What do you think they're most likely to utilize? It is surprisingly the Pareto principle. So 80% of a company's revenue is generated by 20% of its customers. I can believe that.
It's also future value.
Yes, yeah, I was surprised that it didn't highlight future value because that's what I've used for some of my finance classes. Make your mark in tech. Yes, absolutely. Number 3, solve for W. So we have W plus 3/4 equals 1/5, and they told us to simplify your answer as much as possible. So they want us to go through the steps. Pop quiz, okay. So do we think once we solve for W, we get negative 11 over 20, positive 11 over 20? I'm allergic to fractions. Or should we wait until we study linear equations during week 6, which is not a bad idea? Well, let's go through the steps. Again, one of the beauties of mathematics is that there are usually several ways to approach and solve the problem. Feel free to use different techniques than the video version. Here is one way out of many. If you are allergic to fractions like me, you can become a denominator terminator. How? Well, you multiply each term by a common denominator. By the way, a favorite common denominator is the least common denominator. So what numbers are in the denominator of the problem? Well, it's 4 and 5. To find a common denominator, multiply these two denominators. So 4 times 5, which gives us 20. So a common denominator is now 20. So, are you ready to be a denominator terminator? Multiply all 3 terms by that common denominator, 20, or you can look at it as 20 divided by 1. So again, 20 to each term. So rewrite with common factors. So again, if you recall, we got 20 by taking the denominator of each, so 4 times 5. That makes it easy when you're doing the math because you can cancel. Oh, yes, here's the fun part, exactly. Cancel like terms, this is fun. So you get to go, boom, the 4 is gone, and boom, the 5 is gone. So what's left? I mean, again, the 1s cancel out as well. So we can now multiply what's left. We have 20 times W, and then we have plus 5 times 3 divided by 1, and that is all equal to 4. So now we can start simplifying. So again, we have 20W plus 15 divided by 1 equals 4. We can simplify further because anything divided by 1 is just itself. So we really have 20W plus 15 equals 4. And now we can start solving for W by isolating it. Well, how do we isolate it? By taking the opposite. What's the opposite of adding 15? Well, it's subtracting 15. So via the balance method, or otherwise known as reverse engineering, subtract 15 on both sides of the equation. So we subtract 15, it cancels out on the left side, and we see on the right side we have negative 11 left. So again, we're going to keep solving for W by isolating it. Well, what is the opposite of multiplying by 20? It's dividing by 20. So via the balance method, again, a reverse engineering, divide both sides of the equation by 20. So in doing so, the left-hand side cancels out. Again, boom, boom. So we are left with W is equal to negative 11 over 20. You've solved the problem, but here's a different technique. Same problem, but different technique. Are you a fan of pie charts? If so, here's some green apple pie. All right, so here's the different slices of 20. So again, I see it looks like we went up to 15 by 20. Yep, 15 divided by 20 equals 3 times 5 divided by 4 times 5. Again, the 5s cancel out. So really 15 divided by 20 is the same thing as 3/4, which is that first term we have on the left side. Yes, there's 3/4. So again, we have negative 1 of 20, negative 2 of 20, 3 of 20, 4 of 20, 5 of 26, 7 of 28.
A lot of pie, aren't
This
they?
is such good pie. There we go. So now we can see we had 3/4 originally. Now we subtracted that 11 out of 20 from it. And what's left? Well, we have 1 out of 20, 2 out of 20, 3 out of 20, and 4 out of 20. That number is important because, again, 4s can cancel out. We see that 4 out of 20 is the same thing as 1/5, which was the number on the right-hand side. So again, it's a different technique to figure out what the answer for W was, but at the end of the day, you get the same answer. So that's the beauties of mathematics part, is you can look at it, visualize it differently. So, by the way, no one, again, we want to make this clear, no one is expected to know all the topics on the initial knowledge check. The material you happen to miss as you're going through the initial knowledge check will be thoroughly covered during the 8-week session. So don't feel bad. Again, the more information you know and the problems you solve correctly, it is less topics that you will have to go through in ALEKS's pie chart on the back end. But do not fret if you don't know the topics. We will cover them this semester. All right, here's another discussion topic you can use. Recent use of math. Name 3 ways you have used mathematics over the past week. Explain the general circumstance in the math that was used, such as addition, subtraction, multiplication, division, powers, roots, algebra, geometry, trigonometry, statistics, percents, and measurement. Whew. Select the incorrect statement. Using a recipe, here is 1/4 cup of milk. The fuel gauge reads approximately 3/4 full. During a half-price sale, an item originally priced at $50 has been marked down to $30, half off everything. According to the guide sign, the exit to the PA, Pennsylvania Convention Center is 2/5 a mile away.
It says 4/10, but when you reduce 4/10,
That is 2/5.
That is 2/5.
So
Sneaky.
very sneaky. So what is the incorrect statement? It is actually the third one, because half off everything means that it should have been $25, the markdown, not $30. So they're being deceiving. And with that, I will turn over to Professor King for number 4. Ooh, fun.
Use the distributive property to remove the parentheses, and we're given 4a to the 5th parentheses, 6aq plus 10a. This particular problem may be new to you. We covered it during week 8.
Yeah, there it is. Yep, week 8.
So, here's a pop quiz. Let's wait until we study simplifying expression with exponents in week 8. Or you can try to guess what the answer is. Notice all the coefficients are the same. So 24 and 40. It's only the exponent that has changed. Alright, let's solve for those exponents. Are you ready to become a Power Ranger?
Yeah.
Which one are you? The blue one? The red one?
The blue one, for sure.
Okay, let's talk about the language of algebra first. Again, because this is new to some of you, We're going to go through a lot of detail. So here you go. We give an example 1, 2 to the third power, or 2q. How do you say that word?
Faux Paul.
Okay, what he said. 2 to the third power does not equal 2 times 3. Don't bring that exponent down. Although it's very tempting to do that. That 2 to the third power really means repeat the base as many times as the exponent said. So you're just repeating 2 as many times the exponent said. The exponent said 3 times. So 2, 2, 2, and multiply. Now, let's keep talking about this a little bit more. Okay, so the 2 is the base. The 3 is the exponent. And you can say this as 2 to the third power, or 2q, or 2 raised to the power of 3, or 2 raised to the power of 3. There's many ways to say that. Now, let's look at another example. Example 2. We're given 5a raised to the fourth power. Here's another definition. We're still exploring the language of algebra. A variable is an unknown quantity whose value can change. It is often represented by a letter, for example, x. What is the variable in the above expression? Well, there's not an x, so it can't be x. It is the letter A. So A is the variable in that particular expression. There's also another mini definition. A coefficient is a numerical or constant quantity multiplying to that variable or letter. It is typically placed in front of the said variable or letter. So what is the coefficient in the above expression? Well, the number in front of that letter A is 5, and 5 is the coefficient. Let's keep on exploring the language of algebra. How you say that word again?
Faux Paul.
Okay, a common mistake is, okay, see the exponent 4, so just repeat everything 4 times? Not exactly. You only repeat what's immediately to the left of it. So, since the 5 is not immediately to the left of that exponent 4, it's not repeated, just bring it down. But the variable a is immediately next to it, so it gets the bam, 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 a 4 times. Okay. So special note, the exponent only applies to the value to its immediate left. Okay, so continuing the language of algebra, the base is A. Okay, the exponent is 4. The expression could be said as 5 times A to the fourth power, or you can say 5 times A to the power of 4, or just power of 4. There's many ways to say it. Another law of exponent is anything to the first power, you don't have to have that number in the power. For example, 6 raised to the first power, you can just simply write 6. We understand the invisible 1. Here's some more laws of exponent, many laws of exponent that we will cover during week 8. Okay, the multiplication rule. If you have the same variable, such as x, one of the x's is raised to the m exponent, the other x is raised to the n exponent, but the variables are the same. If the variables are the same, there's a nice shortcut. You can just add the exponent. And let's see how this works out. Okay, so we got a squared times a cubed. I'm going to rewrite a squared doing this the long way. I'm going to rewrite a squared. You may recall that means repeat the base twice. So I'm going to repeat a twice. So that's a times a. Likewise for a cubed. I'm going to repeat that 3 times. So a times a times a. So that's how many a's we have in the problem. There's 5 of them, so it's just a raised to the 5th power. That's doing the long way, writing it all out. You're more than welcome to write it all out, but there is a shortcut. The shortcut is, if you multiply like bases, just add the exponent, and you get the same answer, a to the 5th. But again, you can do it the long way or the shortcut way, or whatever way your brain is wired. Just get the answer, a to the 5th. We have more laws to discover here. but fly higher with books, and your books are free is in the ALEKS platform. Here's another property. I'll let you cover this one.
Sure, yeah, cumulative property of addition. So we have an A term plus a B term, and that's the same thing as writing a B term plus an A term. Let's go through the example. So we have 3 plus 4, which is 7, and that is equal to 4 plus 3, which is also going to be 7. So again, we have 7 stars on the left side, 7 stars on the right side. Doesn't matter the position of 3 or 4, it can be 4 and 3. But either way, 7 is 7. So you can add in any order without changing the sum. Now, here's a cumulative property, or commutative, there we go, property of multiplication. I knew it didn't sound right. So we have an A term times a B term, which is equal to a B term times an A term. So they give an example of 3 times 4, which is 12, is the same thing as 4 times 3. Again, that's 12. So you have a 3 by 4 rectangle. It's the same thing as a 4 by 3 rectangle. Either way, the area is still going to be 12. And that's the difference between multiplying two terms and doing the power. So again, you can multiply in any order without changing the product. And again, book it, read your heart out. Again, review the commutative property below. Properties of real numbers. Distributive property of multiplication over addition. So now we have a term, and it is multiplied to, in parentheses, a B term plus a C term. So now we're distributing that A value to each term in the parentheses. So it's A times the first term, so that's A times B, plus, because we have the plus there, A term times the last term, that's C term. So again, we are distributing A to each term inside of the parentheses. And again, you can review this in your book. Today a reader, tomorrow a leader, exactly. So let's look at an example. So we have 2, and it's being multiplied to parentheses 3 plus 4. So that's like saying 2 times 3 plus 2 times 4. And again, that gives you 6 plus 8, which guess what gives you 14. Now, of course, you could have added 3 plus 4 inside the parentheses to get 7. 2 times 7 gives you 14. But this is just showing you that distributive property. Or I guess there it is. I jumped ahead. There's the shortcut. Yes, exactly. Perfect. Law of exponents. Okay, so we, again, as Professor King mentioned, anything to the power of 1 can be omitted. It's the same thing as itself. So according to the symmetric property of equality, again, x can also be called x to the first. So we're doing that for 10a, just again as a visual. If you already know the answer, feel free to jump ahead. So again, we're going to represent 10a as 10a to the first, because again, to the first is just itself. Yeah.
So now we're going to cover the distributive property of multiplication of addition. Thank you for going through all the laws.
Fun laws.
Oh boy. Okay. So recall, to distribute, you're going to distribute the term on the outside to each term inside the parentheses separately. So we're going to take A times the first term and A times the last term. We're going to do the same thing with this problem up in the top. So we're going to take 4a to the 5th times the first term, 6a cubed, and we're going to take 4a to the 5th and multiply it to the last term, 10a to the 1st. Okay, so notice the 4 and the 6 are, according to the language of algebra, those are coefficients.
Mm-hmm.
So we can multiply those according to the commutative property. Likewise, a to the 5th and a to the 3rd, they have the same base, the variable a. We can multiply those too. So here you go. Using the commutative property of multiplication, I'm going to put the 4 and 6 together, and put the coefficients together, and I'm putting the like bases together. Okay, now let's multiply 4 times 6 is 24. But we don't multiply bases like that. Okay, we're going to do this the long way, but there's a shortcut. The long way is write out all the a's. Okay, a to the fifth power means there are 5a, and a to the third power means there's 3a. So that's how many a's are together? 8a. So that's 24a to the 8. But there's a shortcut. So let's go to the lovely shortcut. You may recall when you multiply like bases, you can add the exponent, not multiply.
Yes.
Okay, multiply the coefficient, like 4 times 6 is 24, but add the exponent. Okay, so 5 plus 3 is 8. So we do get the same answer. So no matter how you do it, how your brain is wired, make sure you get a to the 8. Things are different first for that last term. The 4 and the 10 are coefficients, so we're going to put them together. And the a to the fifth, a to the first are like bases, so we're going to put them together according to the community property. So we're going to put the 4 and 10, the coefficients together and multiply. And the variables, a to the fifth, a to the first, put them together and multiply. But we do multiply the bases differently. Okay, so 4 times 10 is 40. Now we're going to multiply the bases. But I'm going to go ahead and go through the shortcut. The shortcut is when you multiply like bases, add the exponents, and we are done. So the final answer is 24a to the 8 plus 40a to the 6. Again, you're more than welcome to do this the different ways. Just make sure you get the same answer.
Perfect. Again, optionally, though we always recommend double checking your work, take a moment to play around with prompt engineering and different generative AI tools. It's a fun way to double check your work. So I personally use Claude for my master's program. Gemini has just released, I want to say, a new model that is supposed to be even the golden standard now. So again, AI is going to be a major tool in the workforce in the future. Please take a moment to play around with it, learn something. The brain and math. Find 2 interesting facts about the brain. One must be about the brain in mathematics. Identify the correct statement. Recent research indicates that the stronger the activation in the left angular gyrus, the better a person's arithmetic skills are. Recent research indicates that the stronger the activation of the right angular gyrus, the better a person's arithmetic skill. Neuroimaging studies have revealed no link between mental arithmetic calculations and the angular gyrus, or the angular gyrus is so called because it is the region in the brain that performs angular calculations. Yes, it's got to be that one.
It's a physics joke.
Yes. But no, it is the left angular gyrus, the better person's arithmetic skills. And with that, we are alive for 5. Simplify the following. Oh, this isn't too bad. So we have 6x in parentheses, and it is raised to the power of 2, or it is squared. Write your answers without the parentheses. Pop quiz. So what do we think our answer is using the distributive property to remove the parentheses? Do you think the final answer is 6x squared, 36x, 36x squared, or 6x? Well, let's go through the steps. Okay, so we're going to use the power of a product rule. So this states that if we have an a and b term inside the parentheses, and if it's raised to the m term, then it's really we have a raised to the m term or b raised to the m term, or basically everything inside of the parentheses gets individually raised to that power or term. So again, a to the m term, b to the m term. And that is the power of a product. Oh, math test, let's see. I need to get I hate math. Wow, whoa, you're using very creative strategies to try and solve these problems. Do you think you can teach them to me later? I'm sure. Thanks, keep up the hard work. Math is okay. Math is okay. That's a good one. So again, we're going to use that power of a product rule here. So we're raising 6 to that term, which in this case was 2, so squared, 6 squared. And then we also have x being raised to the power of 2, or x squared. So we have 6x squared and x squared. Now, we can do some simplification. We can take the squared and just make it each term. So 6 times 6 times x times x. 6 times 6 gives us 36. X times x gives us x squared. So guess what? Who's awesome at math? You are awesome at math. All right, but some of us have a fear of math. Why are some people fearful of mathematics? Ooh. Do a little research and report back on what you find. Select the correct statement. Math anxiety can start as early as first grade. Some people have the math gene and others don't. Speed is a measure of your ability in mathematics. It is wrong to count with your fingers. Well, I've been doing it wrong for a long time. What do we think is the correct statement? It is math anxiety can start as early as first grade. Yep. But we want to fix that. Select the incorrect statement. Researchers estimate that approximately 20% of the population suffers from math anxiety. Having math anxiety does not necessarily indicate that you are bad at math. You can be good in math and have math anxiety attacks. Maryam Mirzakhani, who was the winner of the 2014 Fields Medal, which is the most prestigious award in mathematics, suffered from math anxiety. Or if you are good at math, you can't have math anxiety. What is the incorrect statement? It's the last one. And again, it kind of goes along the lines of the statement in B. You can be excellent and excel in math and still have math anxiety. Number 6. Use the distributive property to remove the parentheses. Ooh, simplify your answer as much as possible. How fun. So in our pop quiz, do we think it's Power Rangers time, which it is? Should we wait until we study power rules during week 8? That's not a bad idea. Do we think it's 72a cubed plus 18a to the 5th, or do we think it's 72a to the 4th plus 18a to the 5th? Must be one of these. You're so close. Well, we're going to do law of exponents. So again, recall that x is also equal to x to the first. That's the same value. So again, we're going to add the invisible 1 to our a just to help as we're going through the distributive property. So we're going to use advanced simplification.
Kind of conflicting terms.
It's so simple, it's advanced. Okay, so again, we're using distributive property of multiplication over addition. So we're going to take our a term times our b term in the parentheses plus a times the c term. It's just a fancy visual. So let's go through the steps. So we're taking 9a cubed and we're multiplying it to the first term, which is 8a to the first, as you can see here. Then we're going to do the same thing again, plus 9a cubed times the second term, which is 2a squared. So we can take our coefficients and move them, and then we can also take our like bases and move them to make it easier to multiply each or simplify each. So we're going to take 9 times 8 using our commutative property of multiplication. So that's 9 times 8, which is going to give us 72. And now we can take our last term, which again, since they're like bases, we can, and being multiplied to each other, we can just add their power. Or again, the long way would be to write it out. So you have a times a times a times a, which is 4 a's, which means it's really a to the 4th. Again, you could have shortcutted it if you'd like. More law of exponents, this case multiplication rule. Again, this is that shortcut I was mentioning earlier. So we could just add their powers together instead of multiplying it out because we are Power Rangers. That is what we do. Please always jump ahead.
Yeah.
Save yourself writing it out. We're just doing it the way that ALEKS does it. So we have 72a to the 4th. So that's the first term done. Now we can work on the second half. So now again, we're going to take our coefficients, put them together, and we're going to take our like bases and put them together. So let's make it so. We're going to take 9 times 2 using the commutative property of multiplication. And then we have a cubed times a squared. So 9 times 2 gives us 18. And again, feel free to use a calculator here. And then we're going to take our like bases, but we're Power Rangering it this time. So we're going to take, it's really 3 plus 2. So really we have 18a to the 5th. So we have now completed the problem. Thank goodness it is over. The real question that we have today, when did math begin? Who started this mess? Determine when each of the following branches of mathematics first appeared in human society. Be sure to name the year or age that each was first developed and who was primarily responsible. Here are the following topics to research: arithmetic, algebra, and geometry. My least favorite was geometry. Oh. Select the incorrect statement. The Ashango bone, which we see to the right and is approximately 20,000 years old, appears to be notched with a table of prime numbers. The same bone, which is found in present-day Democratic Republic of Congo, is carved with 3 columns. One of the columns appears to be a list of odd numbers. The Ashango bone may have been used as a calculator engraved with multiplication and division tables, or the bone is an ancient version of bone dice. What do we think is the incorrect statement? It is the bone dice, absolutely. Yes, that bone had many uses. Very cool. Over 20,000 years old.
Yeah.
But hey, we are here to create your story. Number 7, we are halfway there. Solve for W. We have 4W plus 2 minus 4 times negative 2W minus 1, and that is equal to 2 times parentheses W minus 4, and we are asked to simplify our answer as much as possible, which means they want us to do the work. So, do we think that in the pop quiz the answer is to wait until we study linear equations during week 6? That's not a bad idea. Do we think that once you simplify everything, W is equal to negative 7/5 or positive 7/5?
Do throw that bone dice.
That bone dice, yes, it's a 50-50. All right, are you ready to be a problem solver? Again, life is about solving for X. One of the beauties of mathematics is that there are usually more than one way to approach and solve the problem. So again, feel free to use different techniques in the video version. But here's one way out of many. An initial strategy is to simplify each side of the equation. So we can use the distributive property of multiplication over addition to start solving the left side first. So we have negative 4 times the first term in the parentheses, which is negative 2W. And then, so there's our first term. And now, again, we need to keep distributing negative 4. We can take negative 4 times our last term, which is negative 1. And then just bring down everything else. So we can continue simplifying. So we can take negative 4 times negative 2W. Now recall, a negative times a negative gives you a positive number. So it's really 4 times 2W, and 4 times 2 gives you 8. So it's positive 8W. Now let's do it again. A negative times a negative gives us a positive. So it's really 4 times 1, which is just 1. So we're not quite done simplifying the left-hand side. We want to gather everything together. So since we have like terms with W, we really have 4W plus 8W. And using the commutative property of addition, we can move the like bases to one side, the coefficients to the other, and start adding. So 4 plus 8 gives us 12. So we have 12W, and again, 2 plus 4 gives us 6. So the left-hand side is pretty cleaned up. We're looking really good. We can now use the same distributive property of multiplication over addition for the right-hand side. We're going to take 2 times our first term, which is W, and then 2 times our last term, which is negative 4. So we have 2 times W gives us 2W, and then 2 times our last term, so a positive times a negative gives us a negative, so it's really negative 8. So we have cleaned up both sides, but we're not quite done. We can keep simplifying further because we need to solve for W. So we can solve for W by isolating it. Well, how do we isolate it? By taking the opposite. What is the opposite of adding 2W? It is subtracting 2W. So via the balance method or reverse engineering, let's subtract 2W on both sides of the equation. So we can go boom, the right-hand side cancels. We are left with 10W plus 6 equals 8. Again, we can keep solving for W by isolating it. So since 6 is being added to W, we can take the opposite by subtracting 6. So again, via the balance method, let's subtract 6 on both sides of the equation. The left-hand side cancels out, and we see that 10W equals negative 14. We are almost done. One more step. We can keep isolating for W. So since it is being multiplied by 10, we want to do the opposite, which is dividing by 10. So via the balance method, we will divide both sides of the equation by 10. Thank you. So boom, the left-hand side cancels out. W is isolated, and we see that it is equal to negative 14 over 10. But we're actually not done because it can be further reduced. So we want to reduce to lowest term. So 2 happens to go into both the numerator and the denominator. We can cancel that out, and we can finally see the final answer, which was in the pop quiz. W is equal to negative 7/5. It has been simplified as much as possible. They can't make us do any more. But if you're interested in testing your solution, which you do not have to, substitute your answer in the original equation. So we can substitute W to be negative 7/5, and if you work it out, you'll see that the left-hand side eventually equals the right-hand side. So hashtag stay strong. So again, this is working through the steps, la la la, we're leveling up, woohoo! Working through the steps. We're using our brain power, working through the steps. Huzzah! The left side equals the right side. It means we have the correct answer. We can hashtag so obvious. We can move on. Okay, so now we're talking about geoglyphs. What are Nazca lines? What are some of the geometric shapes found in these lines? Which of the following describes a Nazca geoglyph? Is it the spiral of a monkey's tail as we see on the right? Is it the rectangular ears of a moa? Is it the triangular legs of cattle? Or none of the above represent Nazca geoglyphs? What do you think? It is the spiral on a monkey's tail. They're all really cool. Think big. We are thinking big. And I will pass it off to Professor Keene, who is great for 8.
Okay, simplify. X raised to the negative 5th power times x cubed. Write your answer with positive exponent only, and you will not get any part credit if you have a negative exponent, even though it may be correct. Okay, so do you think the answer is A, Power Ranger activate? Let's wait until we study the power rules during week 8, which is good advice. The answer is 1 over x squared or x raised to the negative 2. Well, let's find out. Are you ready to be a Power Ranger? Yes! Okay, let's refresh our memory on the multiplication rule. When you multiply like bases, the shortcut is to add the exponent. But you can still do it the long way. For example, if you have a cubed times a squared, excuse me, I'm lying.
Yeah.
Oh, she's tough.
Yeah, you can say it that way. Yeah.
According to the community property. Okay, so a squared times a cubed. We're going to do it the long way. We're going to split a squared into a times a. Split a cubed into a times a times a. So that's how many a's in there? High five. It's a to the 5th. But with Power Rangers, we're going to do the shortcut. The shortcut is to add the exponents, and 2 plus 3 is also 5. So you get the same answer, but you can't do it the way your brain is wired. Okay, so we refresh our memory on the multiplication rule. Today is a great day to learn something new.
Yes.
Okay, thank you.
Yes.
Okay, I think we're ready to tackle this problem. We're multiplying like bases, so the shortcut is to add the exponent. So negative 5 plus 3, so you have a negative 5, 3, so that means there's 2 left over, and it's negative because 5 is the bigger number. So, okay, so the final answer is to the negative second if I took the shortcut. Is that your final answer?
Boom, 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 boom.
Yeah, you knew it. Well, no, because it's not a positive exponent. Sneaky. So we have to learn a new rule, and it's called the quotient rule. Okay, it's a lot like the power rule, but the quotient rule is instead of adding the exponents, you subtract the exponent. Okay, so here's an example. Suppose you're given a to the fifth divided by a to the third. If you did this the long way, you write out 5a's in the numerator and write out 3a's in the denominator, and then the fun part, cancel like term. So the a's cancel, another a cancel, one more a cancel. So all you have left over is a times a, which is a squared. Okay, let's remember that a squared because I want to use a shortcut because we're Power Rangers. Okay, according to the shortcut, you can subtract the exponent. Take the exponent in the numerator minus the exponent in the denominator, and you get the same answer. Bravo! Okay, but keep calm and read on. Because there's a little more details we need to dig out here. Okay, it is true when you divide like bases, you subtract the exponent, but what if this is a little bit different? Suppose it's a cube in the numerator and a to the fifth in the denominator. We're still going to do the long way, write out 3a's in the numerator, write out 5a's in the denominator, and then the fun part cancel. A divided by a is 1. A divided by a is 1. A divided by a is 1. And 1 times 1 times 1 in the numerator is, let's see, it's 1. And a times a that's left over in the denominator is a times a squared. So the answer is 1 over a squared. Did that really work the shortcut way? Well, the shortcut says subtract, and 3 minus 5 is -2. You mean those are the same? Yes, those are the same. Surprise! And you've seen this equivalence in another area. For example, the fraction 1/2 is equivalent to the decimal 0.5. These are likewise equivalent. 1 over a squared is the same thing as a raised to the -2nd power. Okay, so there's one more rule in the language of algebra. According to the law of exponent, if you have a negative power, do the flip. Technically, take the reciprocal. So, whether the negative power is on top or the negative power is on the bottom, do the flip. If it's in the numerator, flip it to the denominator and the power becomes positive. If the negative exponent is in the denominator, do the flip and it becomes positive in the numerator. In other words, a negative exponent just means that the base is on the wrong side of the fraction line. So flip the base to the other side, or to be technical, find the reciprocal. So the world belongs to those who read. So keep reading.
That's right.
We can now answer this question. Again, when you multiply like bases, subtract -5 plus 3 gives you -2, but Alex asked for a positive exponent and they mean it. So do the flip, find the reciprocal, flip it, and the exponent is now positive. So your final answer is 1 over x positive 2.
Yes.
Okay.
What is math?
Yeah, what is math?
What is mathematics? When was it discovered? Where was it discovered? Did they find it under a rock somewhere?
No, that bone.
The bone, yes, the bone. Does mathematics exist in all societies and parts of the world? I hope so. Identify the incorrect statement. Mathematics is more than numbers, just as reading is more than letters. How astute. In 1905, algebra was discovered by Albert Einstein in Zurich, Switzerland. Hey, I've heard of that guy. Ethnomathematics is the study of how literate and non-literate cultures evolve different ways of using mathematics. Mathematics is often described as a language. However, researchers who study the brain may disagree. According to MRI scans, mathematics and language activate different areas of the brain, which means no neural overlap really appears. What do we think is the incorrect statement? It was not discovered by Albert Einstein. As genius as he was and moved mathematics forward, it is much older.
More than 4,000 years, and that the chain of bone indicates 20,000 years.
20,000 years.
So,
explore your possibilities. And we are fine for 9. Let's do this. More simplification. Okay, so in parentheses, we have negative 7v to the 4th divided by u, and this is all being squared. And they want an answer without the parentheses. So do we think that once you simplify, you get negative 49v to the 8th divided by u squared? Should we wait until we study simplifying expressions with exponents in week 8? Do we think it's 49v to the 8th divided by u squared? Oh, instead of negative, yep. Or do we think it's negative 14v to the 8th divided by u squared? Well, let's go through the steps. So again, we're using a lot of laws of exponents, so power of a product rule. So we have an a times a b term inside of a parentheses, and it's raised to an m term. So again, that m gets distributed to each term inside of the parentheses. So a raised to the m, b raised to the m. Cool. Let's see. Let's look at an example. So we have 6x and it's raised to the power of 2, or it's being squared. So we're going to square the first term, which is 6, square the last term, which is x. If you write it out the long way, you get 36x squared. And again, you could shortcut it if you already see the answer. So thanks for reading. Now we have power of a quotient rule. Okay, this is a little different. So we have an a term divided by a b term, and it's raised to an m term. So like the multiplication or product rule, again, we will distribute that m term to each term inside of the parentheses. But notice the division is still there. So we have a raised to an m term, and it's being divided by b raised to an m term. That's the key difference. A is raised to an m term, and b is raised to an m term despite it being in the denominator. So let's look at an example. So we have 6 divided by x, and this is being squared. So again, we're going to square the numerator term and square the denominator term. So again, 6 squared is 6 times 6 divided by x times x, which is going to give you 36 divided by x squared. That's still the long way to do it. You could Power Ranger it if you want to, but it makes sense. So you have graduated from being a bookworm to a book dragon. Yes, dragons are cooler. Okay, so again, power of a power rule. This is also new. So a is raised to the m power inside of the parentheses, and that is being raised to the n power. So now this might seem more confusing because this is what your brain wanted to do initially, but now you're taking the m term times the n term versus adding them. So let's look at an example. So we have x squared, and it is being raised to the third power. It's being cubed. So that's like saying x squared times x squared times x squared. And as you can see, there's 3. So again, that's really x times x times x times x times x times x. Again, the long way, but if you crunch them together, you get x raised to the 6th power. That is where that property comes into play. And again, I love my shortcuts. You could also have just wrote it out as x raised to the power of 2 times 3, which again, Power Ranger gives you x to the 6th. We are good to go. So we are climbing the ladder of success via books. So we have, okay, negative 7 times raised to the first term, raised to the power, so we have negative 7 squared. We're also going to have v fourth that's being squared. And then again, recall we have the denominator value that needs to be squared as well. So we can write it out the long way. We have negative 7 times negative 7. Then we also have v times v times v times v squared divided by u times u. So negative times a negative gives you a positive. So we have positive 49. We also have our v term and our u term. So again, just further writing it out the long way. If you already see the answer, feel free to jump ahead. But yes, that is our v times v times v squared. It's just, again, v times v times v. So there are 8 v's. There are 2 u's. So if you recall earlier, I mentioned a negative times a negative is a positive. So 7 times 7 gives us 49. Since we have 8 v's, that means it's v raised to the 8th power. And we have 2 u's in the denominator, which is the same thing as u squared. So again, 49 v to the 8th u squared. And again, if you want to be a Power Ranger and take shortcuts, please do. Speaking of, here's our shortcut. So again, negative 7 squared, b to the 4th squared, u squared. We can write out negative 7 times negative 7, but we can also write out v is raised to the 4 times 2. U is already squared, so now we have 49 b to the 8th u squared. And again, I encourage the shortcut way for sure. Eureka! I've done it. What is the Eureka effect? Give a history on this term. When was the last time you experienced the Eureka effect? Please explain. So we have the hero, king of ancient Sicily. He commissioned a new crown, but the king suspected that the goldsmith had not made the crown of pure gold. So let's see. So we have the crown. He said, "What is his full name?" He's tried to cheat us. So it wasn't made of pure gold, but had mixed in some less costly silver. So the king asked Archimedes to find out if the goldsmith had pulled a fast one. And so he's like, "Hey, don't slip up on this." And he's like, "The great Archimedes, never." So Archimedes racked his brain to no avail until he took a bath. And you can see he's with some ducks that are going quack, quack, quack. Archimedes noticed that the water spilled out of the bath as he placed his body in it. Kersplash! He realized that by measuring the amount of water his body displaced, he could measure his body's volume. And so the duck got wet and was like, he could have used a little less volume. So Archimedes dreamed up an experiment. Scratch, 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 scratch. First, he would find a bar of pure gold that weighed exactly the same as the crown. Then he would drop the gold bar into a full jug of water. So this is important that it's filled to the brim. Kersplash! So the gold bar, of course, is going to displace some of the water inside of the jar. He then removed the gold bar so he could measure the volume of the gold because the difference in the level of water. And he would do the same thing. He would fill it back up with water, and then place the crown in it, kerplunk. So if the drop crown was made of pure gold, then it should displace the same amount of water as the gold bar. So there should be no spillage in this case. But if the crown displaced more water than the gold bar, splash, that means the crown must contain silver. And he's like, "Why?" Because he got splashed again. So Archimedes knew that the substance had different volumes and densities, such as, 5 pounds of lead is denser than 5 pounds of feathers, as we can see from a size standpoint. He also knew that gold is denser than silver. So silver has greater volume and would displace more water than gold. As you can see, 5 pounds of gold is a lot smaller than 5 pounds of silver, even though they weigh the same. So, since it's more volume, if the crown caused spillage, Archimedes could conclude that the crown was not pure gold. There was another less dense substance, i.e. silver, is mixed in with it. And Eureka! Archimedes was excited about his new concept. Legend has it that he was so excited that he jumped from the bath and ran naked through the streets of Syracuse shouting, "Eureka!" Archimedes carried out the experiment. The crown was found not to be pure gold, and of course the king was like, "You figured that out in the bath?" And he was like, "How did you guess?" That's a fun story. Number 10, fill in the blanks. Find the slope of the line passing through the points -7, 7 and -7, -9. So we need to find the slope of that. We also need to find the slope of the points -6, -6, and 5, -6. All right. Pop quiz. Okay. So once we get through the steps, do we think that the answer is 0? It's undefined. It's -7. Or let's wait until we study slopes during week 7, which is not a bad idea. Well, let's start going through it. So we definitely need a graph. So thank you, Desmos. So you can think of the terms in the parentheses as an x term and a y term. So a term along the horizontal and a term along the vertical. So we labeled the first set of points x1 and y1. So again, our x1 value is -7. That's our horizontal value. Our y term, which is the vertical, is +7. So there's a point where they intersect, and that is what again, there's a point of intersection between -7 and +7. So we're going to put a dot there to represent it. So now we have our second set of points. We have -7 and -9. So that is our x2 term and our y2 term. So we're still going to hover over the point -7. And now we're going to go down on the vertical line to -9 for our y term. We're going to look at where they intersect, that point of intersection. And we are going to put a dot there and show that we now have our second term, -7 and -9. So again, that's the visual representation. What the slope is translating is that you have your y terms and your x terms. And so you want to take your y terms, subtract from each other, y2 minus y1, and x2 minus x1. So we have -9 minus 7. So that's in the numerator. Now in the denominator, we have our x2 term, -7, minus our -7. So again, a negative times a negative gives you a positive. So we really have -9 minus 7 in the numerator, -7 plus 7 in the denominator. So now we can start combining like terms. So -9 minus 7 gives us -16, and -7 plus 7 gives us 0. Uh-oh, we can't have a 0. What do you do when you divide by 0? Well, 0, let's see, -16. Stop. Ah, this is what happens when you divide by 0. The world ends. What it really means is that the slope is undefined, so they don't intersect. So you can't use the slope formula. So what does that say? Come on in, we're sloping. That's right.
Did I open with sloping?
We're sloping, that's right. So that was the first part of the problem. Now we need to do the same thing, find the slope for the second part of the problem. So in doing so, do you think that the answer is 0? Do you think that it's going to be undefined again? Do you think that it's -6? Or do you think that we'll be sloping in week 7, which is not a bad idea? Well, again, we can apply the same property. We're going to have our x1 term, our y1 term. So our x term is -6. Our y term is -6. So we can look at that point of intersection, which is there. And we can kind of put a click there so that we know -6, -6. Let's do the same thing for our second set of points. So we have x is +5, x is -6. So again, we're looking at the point of intersection between the three, and we can click. So we have our both terms. So now we can use our slope formula. So again, y2 minus y1 divided by x2 minus x1. So our y2 term is -6. Our y1 term is also -6. So it's -6 minus -6. Then we have our x term, which is 5, minus our x term, which is -6. So 5 minus -6. Again, negative times a negative gives you a positive. So it's really -6 plus 6 divided by 5 plus 6. So that means our numerator is 0, and our denominator is 11. So, okay, 0 divided by 11. Well, if you put it in a calculator, it gives you 0. So that means it is a straight line. So we went from having a heartbeat to no heartbeat, which is what you don't want to hear. So you found your last answer was 0. So the first one was undefined, the second one was 0. But optionally, we always recommend you double check your work. You can check your work by exploring various symbolic AI tools. An oldie but a goldie is Wolfram Alpha for sure. Number 11. We're almost done. We're getting close. A book sold 31,400 copies in its first month of release. Suppose this represents 9.9% of the number of copies sold to date. How many copies have been sold to date? And they want us to round our answer to the nearest whole number. Makes sense. You don't really sell a part of a book. Pop quiz. So do you think that the answer is 317,171 copies? 317,172 copies? Sketchy. Let's wait until we study percent proportions during week 5. Or hey, let's book it. Let's book it. So we're going to identify the parts of a percent proportion, and we will walk through that. So let's say that the full amount is equal to a percentage of it times whatever the base or that total amount originally was there. That is the percent equation. So again, we have the percent P, so which they gave us. They told us 9.9% have been sold to date. So a book sold 31,400 in its first month of release, so we know that that is the total amount, and we know what the percentage is, so we're really trying to solve for that base value. So 31,400 is equal to 9.9% times the base. Now, if you recall from the very beginning of the video, we told you that percent, it literally represents to be divide, so it's divide by 100. So we're going to take 9.9 divided by 100, and again, you could do the two-step dance if you want to. But that's equal to 0.099. So really we have 31,400 divided by 0.099 times the base, that value that we're looking for. And so we need to solve for the base by isolating it. Well, how do we isolate? You guessed it, by taking the opposite. So since we are multiplying by 0.099, we want to divide both sides of the equation by 0.099 using the balance method. And in doing so, the right-hand side, it cancels out. Boom, boom. So you see that our base is equal to 31,400 divided by 0.099. So it's going to get ginormous. You got 317,171.717172. Well, but they told us we needed to round to the nearest whole number. So to round to the nearest whole number, check the value in the 10th column. If that number is 5 or greater, add 1 to the digit in the ones column, then remove all the digits to the right, we don't need them, of the decimal. If it's 4 or less, then we would just remove all the decimals and leave it as that number. So what digit is in the tens column? Well, it is 7. And if you recall, it says if it's 5 or greater, we need to add 1 to the digits in the ones column. So is it greater? Obviously, yes, I said it already. Then add 1 to the digit in the ones column and remove all digits to the right of the decimal. So we now have 317,172, and the decimal and everything is gone. I will now pass it over to Professor King for number 12.
Okay, we're gonna do two things. We're gonna find the x-intercept and then find the y-intercept of the line. And we're given the equation -8 plus 5y equals 14. Here we go. As usual, the pop quiz. Find the x-intercept of the line. So the answer is 14 over 5, -7 over 4, or let's wait until we study intercept during week 7. I like the last one. Okay, but let's talk about the intercept method. You see two dots on a line. Okay. If the dot is on the x-axis, it's called the x-intercept. If the dot is on the y-axis, it's called the y-intercept. So just to reinforce, horizontal x-axis and vertical y-axis. So the x-intercept always takes the x-axis, the y-intercept always takes the y-axis. Alright, so intercept method, we're going to check out the x-intercept first. Okay, so the x-intercept is the point on the graph where y is 0. Therefore, to determine the x-intercept of an equation, set y equals 0 and solve for x. So we're given the equation -8x plus 5y is equal to 14. We're going to substitute y to be 0. When I substitute y to be 0, that 0 times 5 becomes 0. and 0 disappears, so we have negative 8x is equal to 14. Now that's an equation, but let's solve it. So how do I solve for a? Well, by isolating it. How do I isolate? By taking the opposite. What is the opposite of multiplying by negative a? Divided by negative a. So via the balance method or reverse engineering, divide both sides of the equation by negative a. So he can the front part cancel the negative a, and we have left over x is equal to negative 14 over a. However, Alex will mark that answer as incorrect because it can be reduced to the lowest term. Since they're both even numbers, 2 can divide both of them. So 2 times 7 gives you 14, and 2 times 4 gives you 8. Cancel out the 2, and you finally have an answer Alex prefers. So the answer for the x-intercept is negative 7, 4. That's the x-intercept, but there's also a y-intercept. So what do you think is the answer to the y-intercept? 14 over 5, negative 7/4, which sounds like the x-intercept. Just saying. Let's just wait until we 7. Okay, but I think the answer is the first one. Alright, anyway, the intercept method. Again, visually, the x-intercept crosses the x-axis. Visually, the y-intercept crosses the y-axis. So here you go. The y-intercept again is going to cross the y-axis, and notice that the x number is 0. That's always true. So the y-intercept is the point on the graph where x is 0. Therefore, to determine the y-intercept of an equation, set each x equal to 0 and solve for y. Okay, the equation is negative 8x plus 5y equals 14. Substitute x to be 0. So 0 times negative 8 is 0, the 0 disappears, so all we have left over is 5y equals 14. We're not finished, but almost. Solve for y by isolating it. Okay, how to isolate? By taking the opposite. What is the opposite of multiplying by 5? Dividing by 5. So via the balance method or reverse engineering, divide both sides of the equation by 5. So here goes. We're dividing both sides by 5. They cancel out on the left side. So all we have left over is y equals 14/5, and that cannot be reduced further. So read to succeed.
Nice. Thank you, Professor. True or false? All odd numbers have the letter E. Not only do all odd numbers in English have the letter E, most of them also end with the letter E. Or do we think that's false? Or do we think may the odds be in your favor? Or I can't even.
Well, let's see. 1 has
Ends
an
with
E.
E.
3 has an E.
Yep.
5 has an E.
Yep.
7 has an E,
but it
doesn't
doesn't
end with an E.
Yep.
It just only said most of them though.
That's true.
Okay, so it's looking good.
It's looking good, and it is correct. Nice. Number 13. Whew, they're making us work today. But we're getting close to the finish line. So we are tasked with simplifying the following. We have y raised to the 4th, and it is being divided by y raised to the negative 4th. And they want you to write your answer with the positive exponent only, of course. They're on to us. So in our pop quiz, do we think that the answer is y to the 8th, y to the 0, exponenting to week 8, which is not a bad idea, or it's just 1? I like 1. So negative exponent rule. Again, recall we have x raised to a negative power is the same thing as 1 divided by x raised to the positive power. Or, you can look at it inversely. 1 divided by x raised to the negative power is the same thing as x raised to the positive power. So a negative exponent just means that the base is on the wrong side of the fraction line. So flip the base to the other side. It's an easy way to remember it. So again, we have y to the 4th divided by, they put an invisible 1, y to the negative 4th on the bottom. So we're going to Power Ranger it. We can flip it. So really we have y to the 4th times y to the 4th gives us, or divided by 1. We can omit the 1 because it's not needed. It's already assumed. So we really have y to the 4th times y to the 4th. And so if you want to write it out the long way, it's y times 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 y. Why? Why so many y's? So there are 8 y's, or it is y to the 8th. So again, you can also shortcut it too. So again, since they are like bases, we can Power Ranger it and just add their powers. So 4 plus 4, again, gives us y to the 8th. Woo-hoo! I believe this is the last one, number 14. Let's do the simplifying. We have 2b to the 4th. To be or not to be, that is the question. Divided by 3a squared b to the 6th. And this is all being raised to the 3rd power or cubed. And they want us to write our answer using positive exponents. So they want us to work it out. So we have in our pop quiz, do we think that it is 8b to the 12th divided by 27a to the 6th, b to the 18th? That's sketchy that there's b's in the numerator and the denominator. But anyway, let's power up in week 8. Or do we think that it's just 8 divided by 27a to the 6th, b to the 6th? That sounds correct. But let's do it the long way. We love the long way. To be. No, I'm just kidding. To be, or which is divided by 3a, b, cubed, or raised to the 3rd power. Again, we can cancel out b's, that is the fun part. So we have 2 divided by 3a, b. Again, it's all cubed. So we can combine our a terms, our b terms, and our 3. So we really have. So it's written out cubed, so it's 2 times 2 times 2 in the numerator, 3 times 3 times 3 times a times a times b times b times a times b times b times a times a times b times b. And we love the long way. So we have 8 divided by 27, etc. So again, we have 6a terms. And then we also have, I want to say it's 6b terms. There we go. So 8 divided by 27, a to the 6th, b to the 6th. We can also shortcut it, which is my way of doing it. So again, since we have terms in the numerator and the denominator, we can take that relationship. So it's really 6 minus 4, which gives us b squared. So we really have 2 divided by 3a squared, b squared. Now we also have, again, the power of 3. So take 2, the numerator, so it's 2 cubed, which is 2 times 2 times 2. In the denominator, we have 3 cubed, 3 times 3 times 3. A squared is being cubed, which is really the same thing as a raised to the 2 times 3 power. And then same thing, b squared is a b times 2 times 3 power. And again, like I said, I'm jumping ahead with being a Power Ranger because we've already solved it. So it's really 2 times 3. So that gives us 6. So it's really 8 divided by 27, a to the 6th, b to the 6th. So much faster. Ta-da! You finished the study guide. Thank you so much for enthusiastically participating in the polls, the chats, the emojis, the Q&A, the notes, etc.